We are now going to look at the cis and trans isomers. And these are isomers. We have looked about the structural isomers. We have talked about structural isomers previously. If you remember, when we were discussing alkanes, we had discussed structural isomers. And alkanes are saturated hydrocarbons with the single bond between the carbon and between two carbons, they have a single bond. So because a single bond, you can twist the molecule around a single bond, you are creating structural isomers with the number of carbon atoms being the same, but the skeleton being structurally different. In cis and trans isomers, we are discussing isomers in alkenes. Alkenes are hydrocarbons with double bonds, and the double bond is rigid. You can't move the molecule around a double bond. So the atom or groups of atoms attached to the carbon-carbons on the double bond may form two different structures, which are called geometric or cis or trans isomers. You can see a cis isomer when you can see a double bond here. This can represent a double bond, and these are your two substituents, both facing the same direction, being the cis isomer, and facing opposite directions to the double bond, they are being called the trans isomer. So in an alkene, the double bond is rigid, like I had said, and does not rotate. So it holds the attached groups in fixed positions, and that makes cis and trans isomer possible when two different groups are attached to the carbon atoms on each side of the double bond. So if we take this molecule as an example, 1,2-dichloroethene. Here, let us review our naming. So ETH is a two-carbon compound. ENE is a double bond. 1,2-dichloro. These are the substituents. So there is a chloro substituent on 1 and 2 carbons. So both carbons, 1 and 2, have a chlorine substituent. So when we set up these molecules around the double bond, we see that when the two chlorine substituents are facing the same direction, you have the cis 1,2-dichloroethene, and when they are facing the opposite directions to the double bond, we call that the trans 1,2-dichloroethene. So these are the cis and trans isomers. You use cis and trans as prefixes to identify the two compounds, cis and trans. Have different physical and chemical properties. The arrangements are different, and that result in different physical and chemical properties. So here again, you can see the two fingers representing the double bond, and the cis hands and the trans hands. In the cis isomer, the alkyl groups are attached to the same side. Here again, we have another example. Here, the substituents are the methyl groups. 1 carbon, 3 hydrogen is a methyl substituent. So this is two groups, methyl groups here, facing the same direction, and the opposite directions comparing the double bond. So we can set up this molecule 2-butene around the double bond to set up a cis or a trans isomer. So this is a butene, 1, 2, 3, 4, but we can set up the bond around the double bond to create a cis and a trans isomer. In a trans isomer, the groups and the hydrogen atoms are attached on opposite sides of the double bond. So you can see the groups are at opposite ends of the double bond in the trans isomer. So this is again a link to the environment. So we see pheromones are chemicals that are secreted by species of moths. So these are pheromones, are chemicals secreted to attract the opposite. You can see pheromones depend on the cis and trans configuration of double bond of the molecules the pheromones are very particular in cis and trans arrangements. So here you can see the pheromone produced by a female silkworm moth. So you can see that this is a trans isomer. And this is a cis isomer. Here, this double bond, you see a trans isomer. Opposite ends. Here you see a cis isomer. And because of this arrangement, the chemical property of this pheromone is significant for the silkworm moth. So, like we said, the cis and trans isomers result in different chemical properties. So this combination gives this chemical the special property that we are talking about. The prefix is placed, again, like I said before, when you have a cis isomer, you identify the isomer using cis. So here you have a cis isomer double bond. The substituent on the same side. Double bond, the substituent in opposite sides of the double bond. So you have the trans isomer, cis isomer. So you use the terms cis and trans to identify the prefix. Now here we can look and identify which of these examples are cis and trans. So here I'm looking at the double bond, and the substituents around the double bond, both the Cl substituents are facing the same direction, these two group facing the same direction. So this is a cis molecule. Here I'm looking at the double bond, bromine substituents facing opposite directions, the methyl groups facing opposite directions. This is the trans example. Here again, I have a trans example. So let us see. Cis, trans, trans. So let's name cis 2,3-dichloro. 1, 2, 3, 4. That is the longest chain. If you want to review, we can do this here. We first count the longest chain carbon chain. So 1, 2, 3, 4. That is bute. We see a double bond, bute, E. Then we are numbering the carbon atoms to number the substituents. So 1, 2, 3, 4. 1, 2, 3, 4. Either way, the chlorine gets the same number. So we are going to say 2, 3, di. There are two chlorine. Dichlorobutene. Here again, we're counting the longest chain. 1, 2, 3, 4. Butene again, there is a double bond and 4 carbons. So 1, 2, 3, 4. 2, 3. 1, 2, 3, 4. 2, 3 in the opposite direction as well. So 2, 3 dibromobutene. Here we are looking at 1, 2, 3, 4 butene. There are no substituents here. There are the hydrogens, so we have trans 2-butene. So 1, 2, 3, 4. The carbon number 2 has the double bond, trans 2-butene.